Hello everyone, my name is JALAN and today we're going to learn about divide and conquer technique. So divide and conquer is an algorithmic pattern, and in algorithm methods the design is to take a dispute on a huge input, break the input into minor pieces and decide the problem on each of the small pieces, then merge the piece-wise solution into a global solution. Hence, this mechanism of solving problem is called divide and conquer strategy. The divide and conquer algorithm consists of a dispute using the following three steps: divide, conquer, and combine. Divide the original problem into a set of subproblems. Conquer, solve every subproblem individually recursively. And combine, put together the solutions of the subproblems to get a solution to the whole problem. Generally, we can follow the divide and conquer approach in a three-step process. For example, the specific computer algorithms are based on the divide and conquer approach. The maximum and minimum problem, binary search, sorting, merge sort, quick sort, and the Tower of Hanoi. Here we can see the algorithmic pattern or the pseudocode for the divide and conquer technique. First, we divide the problems into smaller problems and we conquer each problem, and then we combine every problem to get a solution for a whole problem. The applicability of the divide and conquer technique is as follows. The problem blends itself to division into subproblems of the same type. The subproblems are relatively independent of one another. That is, no overlap in effort. An acceptable solution to the problem can be constructed from acceptable solution to a subproblem. Two kinds of fundamental of technique. First, the relational formula. It is the formula that we generate from the given technique. After generation of formula, we apply DN3 strategy, that is, we break the problem recursively and solve the broken subproblems. And second, stopping condition. When we break the problem using divide and conquer strategy, then we need to know that for how much time we need to apply divide and conquer. So the condition where the need to stop our recursive steps of DNC is called as stopping condition. Advantages of divide and conquer technique. The divide and conquer tends to successfully solve one of the biggest problems, such as the Tower of Hanoi, a mathematical puzzle. It is challenging to solve complicated problems for which you have no basic idea, but with the help of divide and conquer approach, it has lessened the effort as it works on dividing the main problem into two halves and then solve them recursively. The algorithm is much faster than other algorithms. It efficiently uses cache memory without occupying much space because it solves simple subproblems within the cache memory instead of accessing the slow main memory. It is more proficient than that of the counterpart brute force technique. Since these algorithms inhibit parallelism, it does not involve any modification and is handled by a system incorporating parallel processing. Disadvantages of the divide and conquer technique. And since most of the algorithms are designed by incorporating recursions, so it necessitates the high memory management. An explicit stack may overuse the space, and it may even crash the system if the recursion is performed rigorously greater than the stack present in the CPU. Now, these are some of the applications of the DAC technique. The main are binary search, merge sort, quick sort, median of two sorted arrays, in-order, pre-order, post-order tree transversal, multiplying large integral problems, finding maximum and minimum, and Strassen's matrix multiplication. Now let's talk about the merge sort technique. Merge sort is yet another sorting algorithm that falls under the category of divide and conquer technique. It is one of the best sorting techniques that successfully build a recursive algorithm. In this technique, we segment a problem into two halves and solve them individually. After finding the solution of each half, we merge them back to represent the solution of the main problem. Suppose we have an array A such that our main concern will be to sort the subsection, which starts at index P and ends at index R, represented by A. The merge sort function keeps on splitting an array into two halves until a condition is met where we try to perform merge sort on a sub-array of size 1, that is P is equals to R. And then it combines the individually sorted sub-array into larger arrays until the whole array is merged. As you can see in the image given below, the merge sort algorithm recursively divides the array into two halves until the base condition is met, where we are left with only one element in the array. And then the merge function picks up the sorted subarray and merges them back to sort the entire array. Mainly, the recursive algorithm depends on the base case as well as its ability to merge back the results derived from the base case. Merge sort is no different algorithm. Just the fact here, the merge step possesses more importance. To any given problem, the merge step is one such solution that combines the two individually sorted lists to build one large sorted list or array. The merge sort algorithm upholds three pointers, that is, one for both of the two array and the one to preserve the final sorted array's current index. The merge sort has following best case, average case, and worst case complexity. So the merge sort have the best case time complexity of O n log n for the already sorted array. The average case time complexity for the merge sort algorithm is O n log n, which happens when two or more elements are jumbled, that is, neither in the ascending order nor in the descending order. And last, the worst case time complexity is also O n log n, which occurs when we sort the descending order of an array into the ascending order. Another DAC technique is binary search. The binary search algorithm is a searching algorithm which is also called a half interval search or logarithmic search. It works by comparing the target value with the middle element existing in a sorted array. After making the comparison, if the values differ, then the half that cannot contain the target will eventually eliminate, followed by continuing the search on the other half. In the binary search technique, we search an element in a sorted array by recursively dividing in the interval in half. Firstly, we take the whole array as an interval. If the pivot element is less than the item in the middle of the interval, we discard the second half of the list and recursively repeat the process for the first half of the list by calculating the new middle and last element. If the pivot element is greater than the item in the middle of the interval, we discard the first half of the list and work recursively on the second half by calculating the new beginning and middle element. Repeatedly check until the value is found or interval is empty. Now let's talk about the quicksort. Quicksort is one of the most efficient algorithms out there which divides the array into subarrays. It requires an element to be pointed as a pivot and two other elements as referred to compare with the pivot element to get the list of elements smaller and larger than the pivot element on the two different sides of it. Since using quicksort, the problems can be solved by combining optimal solution to an non-overlapping subproblems. The quicksort cannot be determined as a dynamic programming approach. So quicksort is basically a sorting technique in which a collection of n items are sorted into the increasing order. The algorithmic steps are given as follows. Break the list into two pieces based on a pivot. The pivot is usually the first item in the list. All items smaller than the pivot go in the left and all items larger go in the right. Sort each piece, recursion again. Combine the results together. And hence, the quick sort is basically preferred over when arrays are needed to be sorted, whereas merge sort is better when it comes to sorting linked lists. No additional space is required for quick sort, but merge sort requires a temporary array to store the element. Here you can see a basic difference between the quick sort and merge sort techniques. In the quick sort, the splitting of an array of an element is in the any ratio, not necessarily divided into half. The worst case time complexity of quicksort is O n square, whereas in merge sort it is O n log n. The quicksort technique works well on smaller arrays, while merge sort techniques operates fine on any size of an array. The quicksort technique is inefficient for larger arrays and Q.